Hi, my name is Massimo Yezzi. I am the Chief Technology Officer of Interlock Technology, and I'm here to show you a demonstration of DATAFORGE, our product for data transformation and migration. Basically, here's our dashboard, right, which shows all of our jobs, all of the different types that we support. As you scroll through, you'll see here's our job name, whether the assessment and migration was completed or not of that particular job. And if at any point we wanted to check on the status of a job, we can simply click on the job name. Here in this screen, this is an information screen about a particular job that we've set up to migrate some data. This is between one NAS share to another. I'd like to just take a quick step back here to talk to you about some of these info blocks. So this is a sync job. What this means is that this is a job on a live file system. So it will constantly scan the source to find changes after, if you look here, an idle period of 7 days. So instead of constantly scanning a source for data and changes, we like to give it a rest. And it does this all automatically. As it finds any changes, it will just simply copy them from the source to target. And this will constantly go for every 7 days, essentially.
I had a question about the what you are showing, in the sync job. Does it mean when it says that it's paused, it means that in fact it is running and active, but it's paused because it has detected no activity on the source file system?
Oh, no. So this is great. So we actually have a couple of different statuses that you can select from this main screen, right? So a job that is ready means it's completed at least one portion of the job. So maybe that's where I need to start. We have when we perform a data copy, right? We need to first assess the content so we know how much data is there. That is our assessment phase, and as you can see here, some of these are in a variety of different stages. This is, QA. When we assess and we're complete, that means we're ready for migration. So in a case like this, where I'm looking for jobs that are ready, if I clicked on this, I could click a new phase here. So now we're ready to start, an assessment. This is actually going to go out and scan and look and see what's on this target. It'll build a list of files. Some of these are specifically set up so they'll fail, right? Obviously, because it's like, QA. But basically, once this is done, do you see over here where it says like I could start migration? Mm-hmm. This job is now considered like a ready status. So if I hit start migration, now this will start running. However, if I click pause, right, it'll actually put it into like a pause status. So if I actually come in here and I look at pause, these are jobs that were launched and then somebody clicked pause, or they're paused by the scheduler.
Sorry, yeah, I got another question, because if you get back to one of the screens you had there, I've seen somewhere ready for phase 4. So does it mean that, in fact, the whole migration effort that you have goes through several phases, several stages to from beginning to end somehow?
Yes. So with a sync job, this is almost like fire and forget until you're ready to perform what Noemi called earlier a cutover event. So when you have a live file system and the data is constantly changing, one of the biggest challenges is how do you keep that up to date, especially when some of these migrations can run for months and months and months. So the concept of a phase is simply that if I select an earlier phase here for for example, this job, which might have been run a couple of weeks ago, this will tell me I found 30,000 objects. It was 70 kilobytes. It was migrated for phase 2. This was the next time that it happened, phase 3, and we will report on all of this. So as time goes on, DataForge is actually doing this all by itself when we're in a sync job, like an automatic mode. So it can keep these shares up to date for months and months and months until a migration engineer is ready to perform what's called a cutover. And then at that point, we go into what's called manual mode. And then an engineer can simply force a scan on the source make sure that we've got everything, do the last copy to the target, and then the IT infrastructure can simply switch from the old source to the new target, whether it's a DNS update or something else like that. And now they're completely up to date, right? So that whole file system has been transferred. That's what these concepts of a phases are.
With the sync style jobs, can it be bi-directional so that you've got an actual true sync, or is it just source to destination? You're just constantly updating that way.
It's only source to destination. The
Gotcha.
the destination is assumed to be offline and immutable except for this software and the engineer.
Oh, that's interesting. So it's immutable. So effectively, there's no mapping on the far side that'll allow access to it, or are you putting blocks in place to actually make that destination immutable?
Well, no, keep in mind that the source is what's actually actively being written to for like think of these as home directories, right? What if
Mhm.
you had to synchronize 1,000 home directories? Users are still changing their data on a daily basis. They're only writing to that source. So when we have a cutover event, what happens is that the source and target will generally go in, I'm sorry, the source will generally go into a read-only mode. And at that point, no changes can be made. The engineer will make the last assessment and data copy to the target. And then at that point, the source is brought offline and the target is brought online. So now those very same users who before that window were accessing the source share, if we're talking about NAS, for example, now they're accessing the target share once it's brought back up. So that's why it's considered immutable, because it's not being accessed by the end users yet.
Yep. Gotcha. Thank you very much.
Mm-hmm.
Hi, I'm Noemi Grazer. I'm with Interlock. One thing to add to this is that if you have a really large system, you can carve it up into multiple jobs. So, for example, you can do the migration of let's say one share, just as an example, one share, and you could have some users who are accessing that share, access it on the target if you already did the cutover for that job, and others still accessing data on the target versus the source, depending on how you structure the jobs. So you can have multiple jobs. You're not limited to only one job per system.
Great, great, great answer. Thank you for that.
So, Massimo, I had a question if you have a second.
Yes, yes.
Obviously, this is a very elemental question, but if on the source someone were to delete or rename a directory, which affects essentially its position in the file system, right, or anything like that, obviously that synchronization also happens on the target. Is that correct?
Yes.
Okay.
The way that
Okay.
it would be recorded in our software, just very quickly, is we wouldn't have a direct way to track that a folder was renamed. So what would happen is it would
Hmm.
essentially remove content from the target and then replace it with all the new names.
Okay.
It would
Okay, that
show
makes
as,
sense.
this content's gone and this new content was added. Mhm.
And a follow-up on that, obviously, we've talked about that this is aimed at object storage, right? What if somebody accidentally, I've seen this happen on a source system, they identified a particular set of folders that were actually being written to uh, a group of files on in that folder that were being written to in block fashion. For example, SQL Server database or an Oracle database. Would your software be able to go, oh, we detect kind of a different pattern here because these files are literally being hammered every few seconds, and maybe you didn't do something right there when you set up the copy job, the synchronization job?
No, so for something like that, where you'd really kind of need to use like shadow copy to open or to copy open files, especially those very large database files. But we wouldn't try to get something at like a block level. We would if the file is changed, we'll get the whole thing.
Okay, that makes sense. So it is kind of incumbent on the user to know what you're syncing. That's what it comes down to.
Yes, yes, that's true.
During the assessment process, part of the assessment is to identify not only how many files you have, but what kind of files you have. So during the assessment, if we were to look, we would probably see that this is not, that this is maybe a database file or something else. And the customer or the end user may choose to address it in a different way.
So follow on to that question is, do you actually track the heat of the various different objects and not move the hottest objects until the end of the migration?
Well, see, that's the benefit of a sync job, right? Is that we're, every 7 days and that's configurable, we just simply look for changes and then copy them over. So that way at the end of the job, there isn't going to be like this huge list. We are building some heat maps, so we know like what folders are changed the most frequently. So when we're doing a cutover, what will happen is we want to keep that window as short as possible, right? Because you can't have an outage the whole weekend. I mean, I guess you could, but that's not what we're aiming to do here. We want to keep these outage windows as short as possible. So we do have things like heat maps where as files change, we can build a map in our database that says, hey, this folder has been changed, this many times over time, and it's like, really hot. And then we have some that, you haven't received updates in 6 months. So at the end, when we're all ready to basically perform the cutover, what it'll do is it'll scan the folders that are touched a lot first to see if it can find anything, and then try to migrate that content right away, right? Because sometimes it takes a while to scan a file system, but if you know that you've just synchronized every single folder that has been modified in the last 6 months, and it'll close that window much faster for you, so that way you have confidence that you've got every file in a shorter amount of time. So we do have some kind of tech like that.
We're developing it. It's on the roadmap. It's not a GA currently in this version, but it is definitely on the short list of items that we're looking to bring forth.
There were some questions about scaling out and scaling up, and how to basically like monitor the system. So if you select in the menu here, you can actually monitor the whole deployment, and this will show you the stats that are on the back end. The back end is essentially a Linux OVA. It's a Debian. We have a MySQL compatible database. We have excuse me, just 1 second. Sorry, we'll have to rewind real quick. I wanted to say that we have a modern asynchronous queuing system that's on the back end that can control communication between the back end and all of our nodes. And if we wanted to see the nodes, I could just click this right here, and you'll see now our nodes are Windows only for right now. So our node software is just simply an MSI package. A virtual machine could be deployed in an environment where you're going to perform one of these kind of data migrations. And as you can see here in our lab, we've got Windows 10 as a node, as well as Windows 2012. And if you actually click on the node, you can see a little bit of information about it, like how much memory that our system is taking up compared to how much is available on the system itself, along with how many CPU cores it has and whatnot. When you're running a job, you can actually also see the CPU usage and the actual aggregate network use of your nodes. And this is useful because if you're seeing like an assessment is taking too long or a migration is taking too long, in addition to looking at our own logs, you can use this as almost like a real-time troubleshooting tool to find out what node might be misbehaving. Now we're also in a distributed. I'm sorry, does someone have a question? No? Okay. Now also that we're in an environment where we're using lots of nodes and things are distributed, we're also sometimes migrating off of storage arrays that might be years old. They're unhealthy, right? The replica has gone down. We no longer have access to it. We can actually perform what's called with the performance scheduler. With our software, we can determine when we can actually migrate at a global level. What that means is that if I have a very unhealthy storage array that I want to migrate off of, be it object or file, we can control, say during working hours, if I want it to have what was called a zero impact, which we just kind of set as an example here for days. But what this will do is it will actually limit the amount of threads and connections that we use to our source arrays and our targets. So we have a very minimal impact, but we can still copy data. And of course, if we need to outright pause it, you can see we have another option here where we could set the schedule to pause and absolutely no jobs will run. The last thing I wanted to kind of talk about with the data transformation portion is that when these applications store their content using different protocols, the file structure and the metadata can be completely different from one another. So very quickly, I just wanted to walk through a demo of a migration that I use for NICE NTR, which is a very common off-the-shelf application. It's used very widely in financial institutions. So this was just a copy I did this morning for us so we could see what the data kind of looked like. And I wanted to take a minute here to show you some of the source content. For example, like with the NICE NTR, the data as it appears on SMB would be in this kind of a format where you would have whatever the root is of where you're storing your content. I can choose any kind of a folder here, a subfolder. These are, hours, obviously, when things were migrated. I'm sorry, when things were written to this share. So the way that this would write all this application data is a bunch of WAV files, and then we have a CSV. So each folder will have this kind of a layout. And if I actually open up this CSV here, this I can expand a little bit with the font size. It's a bunch of metadata about each call that was recorded. Now you can't just take this data and write it to S3 or another protocol and expect it to work. It just won't happen. The application won't understand it. So one of the benefits of DataForge and it being application aware is we can take this kind of data and transform it so we can write it to, say, an S3 platform. And I can go into our test content here, and I'll just scroll through here. So what this actually has done is it breaks up all of that content, and it reads the single line of where it should be for that call. So when now NICE NTR retrieves this content from S3, it will understand, here is my call, but now here is also my metadata that goes along with it. And this is exactly how the application writes it. This is one of the strengths of DataForge and why you want to use a utility like this. I don't know if I have anything else really that I wanted to go over with this, other than with some of our jobs, of course, you're going to find some fail, right? You're going to have permissions problems. You're going to have network problems. Sometimes it's just transient stuff. What I like about in the UI, we can find some of those jobs very quickly simply by looking for their status. So if I wanted to find all of my jobs that were in error status, I could say, for example, select maybe this job, and it'll tell us right here that our job failed. And I can actually click on this link, which will bring me to a screen that are all of the errors. And as you can see here, it will tell us on each file what the problem was. And again, some of this is we're doing this on purpose in our lab to for testing. But what you could do is if for whatever reason this path was it transiently unavailable, at this point you would just hit resolve, and what would happen is that in the job itself you could relaunch whatever portion of that phase that you were in, and it will just simply try to copy over that one file. Or if I wanted to, you could click resolve all, and then that would resolve all of these errors and it would reattempt everything.
So a quick question on this. So do you actually have some way of if there's an error, you can roll back to a known good point and start over that.
Well, if you're using a synchronizing job, right, where it's constantly running, the errors are not, I won't say that they're ignored, but what happens is that we know that we're in an automatic mode and that files are, we're just going to have these errors. So for the most part, if we have errors where like a file isn't there or there's an issue with permissions, the job will continue, but it will just list in the job that, hey, there was a permissions problem. And
But
then the migration engineer could resolve it. If it's
in a case where you might potentially have an application that has a set of files that it works on, if one of those files fails to copy, you probably want to go back to a point where you have the correct set of files to move forward.
What would happen is that we would copy everything else. And if there was one file that wouldn't copy, we would just simply list that, hey, this file didn't copy and we need to try and figure out why. It wouldn't fail the whole batch. It would copy what it could. Does that make sense?
Yes, it makes sense. Thank you.
Yes, so I've got a question as well. So it seems to me that really in terms of the whole process, we have three major things. We have the migration infrastructure, we have the replication pairs, and then we have jobs. And thinking in terms of like a shared responsibility model, who is responsible for what in those platforms? Like who's going to do your node deployments, who's going to set up your pairs, and then who's going to actually do the migration?
Sure, that's a great question. So when we engage with a customer and they want to use DataForge, what we'll do is, first off, we have to size it out, right? So we will talk about how much data that they want to migrate, how many data centers that there are where we're going to be migrating data. It could be, 2 or 3 more, regions around the world. So for that, we'll have to work with them to size out the deployment. We could potentially, even if it's in different geographical locations, we could technically use one backend, but the nodes can be installed anywhere. So in a case of deployment, we work with the customer to tell them exactly how many nodes that we might need in each data center, where we should place the backend, and additionally, how many resources should be allocated to each node. Once that's complete, we generally would work within teams, especially if it's in a larger corporation, to get credentials and create these jobs. So this would be all like the migration engineer, who would be everything that you see here on the screen, would be creating these jobs, managing them, and providing reports when they're done. Now, if a customer wanted to do this themselves, then obviously they would deploy DataForge. There we have documentation that describes how to do the sizing, and then they would be able to run all these migrations themselves.
Which actually brings up one question I had, Massimo. Just to be clear, the UI that you're showing us right here for DataForge, is that actually running on that DataForge application node that I think was a few slides back in our presentation?
No, so the nodes just simply listen for requests for work. That's all that they do. Okay. And since this is like a widely distributed system, let's say you have 3 nodes and you're trying to run 2 jobs. The what we call the Forge manager, so that's the back end, right? The Linux machine that has all the brains. That will divide up jobs into work units, and it submits it into a queuing system that the nodes will essentially listen to for work, right? So you could actually have node A performing, job A, and node B performing job B. Node C could also be performing job B. It kind of depends on how they get the work units and the priority of the copy, right? But what I'm accessing right now, this is the back end.
This is the back end. Okay.
So
this is the Linux
system.
Linux system. Okay. So this is another thing. This would run as a VM, just so I'm clear.
Yes. So we have so what Interlock has done is we've created an OVA template that you can deploy to VMware ESX.
Got it.
And that OVA file contains everything you need. You deploy it.
Okay.
You basically add a disk to it for database space, which obviously would help you size out. And as soon as you power it on, it will get that storage ready. It attaches it. It brings up all its services, and you're ready to go.
Okay. Okay. And you mentioned if a customer is going to do this on their own, and maybe you're going to cover this. If so, that's cool. Is there like a sizing tool besides the documentation that you can go, I've got, estimated this much storage that I need to migrate, or file, these many files, this, X petabytes, whatever it might be. Here's what here's a rough guess of how big that configuration should be.
Right now, it's just documentation only.
Okay. Okay. Thanks.
We do have some, from an experience perspective, we have some kind of migrations we have done where we have seen, and we'll talk about it in a little bit, seen that if you size it correctly, you can move as much as 22, 23 terabytes a day in a good solid environment. We also have examples of setting up the system to migrate, 3 billion files in 30 days. So because those are the two metrics that most people consider in terms of performance, right? How much data you move or how many object files you move. So there are ways to design it, and we can reference those, but currently, as Massimo has said, it's only available in documentation.
So I think that I pretty much showed you most of what I wanted to display today, other than maybe a couple of different screens here for maybe like the notifications and the job creation. So if you don't mind, I'll just back up a second and I'll try to just show that real quick. Basically, when you go to create a job in DataForge, it's quite simple, and we support several different sources and targets. Here you can see it simply, if you want to have a cloud-based protocol, such as, for example, NetApp Storage Grid, Dell ECS. We can do a generic S3 kind of a thing, and we can also go to Azure storage. We have traditional SMB, NFS. We have some REST APIs that would access, for example, Atmos, which it's an older storage, as well as Hitachi, HCP REST. So I kind of just wanted to show some of this. Man, I'm fumbling over my words again. And then the other one I wanted to show was notifications. So that's important if you're a migration engineer and you're running some jobs, and you're obviously, migration is a 24/7 operation, but your migration engineer needs rest. So we actually have some most common notifications for your jobs will be displayed up here. And some of the more critical ones, as you could see, like in this one, it'll tell us that our disk space is low. And it'll actually change the color too when they become critical and things like that. So a migration engineer can easily see what all the problems are with their jobs right away in one screen.